All right. Hello, everyone. Welcome to join today's SIG scheduling bi-weekly meeting. Uh, so we have a couple of topics today. So the first one is to answer what's the proposal, which was originally put on the scheduling plugins about one hierarchical cluster topology group schedule plugins. And then this was previously presented in local batch. So what's the brainstorm point out there? Aldo and Asher, do you have any consensus or what are kind of questions or conclusion out there?
Right. So you're right. So originally I wanted to discuss it here in the SIG scheduling, obviously because it's a proposal for a scheduler plugin that does group scheduling as well as cluster topology um, awareness for the group of pods. Um, then there was a suggestion that I presented to the WG batch because there is definitely interest there since we're talking about pod groups or pod sets that would correspond to workloads that are placed all at once with topology awareness, especially that Q is also working on that topology awareness or adding this topology awareness feature to Q. So I presented it I think it was, last week. I think most of you were there. Um, I didn't go into the details of the plugin itself because that's not of interest to that group. But the outcome, I think, the reading is that so obviously we have two things going on here, which is the you know adding this feature of topology awareness, the cluster topology, to scheduling, and whether that scheduling or the mapping of pods to nodes should happen in the scheduler or it should happen at a layer above at the workload scheduler, for example, Q. So Q point of view is we want it to be in Q, and so they started adding that function. Currently, it's a very simple pack at all levels uh, for the workload or the pod set. And the queue would, in addition to doing the typical quota management, queuing preemption, and all of that stuff, also assign not necessarily nodes, but node flavors to the pods, which if you go all the way down to the node level, it's basically assigning nodes to pod, which is basically the function of the kube schedule. So that's the contention, whether it should be way up there in the workload scheduler or in the kube scheduler itself as a plugin. Now, if I have an application that is not necessary, that could be submitted to Q, then I would use Q and the task function, the top awareness scheduling function in there, assuming that eventually it's going to evolve and get more complex, that you can specify a more complex way of placing the group. If I don't, then not having that function in the kube scheduler as a plugin, uh, I don't know what to do. Like then I'm forced to use Q. I'm forced to use Q, meaning that I have to deal with quotas, I have to define flavors and the rest of it. So I don't know if I'm clear, but that's my reading of the outcome of that
Yeah, I think before we come to a conclusion, do you mind that recap, like use 5 minutes to recap what's the high level ideas about the overall design and
Right.
how it will impose the implementation and design details onto schedule plugins versus the
So I'll try to be
IQ.
quick.
Yeah,
Uh,
sure.
can you see my screen here?
Yeah, yeah.
Right. So I'm not gonna go through what is topology awareness. I assume it's understood. So here we're not talking about the topology of a node as other plugins do. This is about the cluster topology. So nodes are the leaves of a tree, and specifically it's a tree, it's not any graph, where nodes are leaves in this tree, and then you go up the hierarchy, however you define it. Servers, nodes, rack, whatever. And so that's on the infrastructure side. On the application side, the thing that is to be placed here is a set of homogeneous pods so far in this work. So like a pod set in Q, uh, could also be a pod group as in co-scheduling. So that's the high level. Again, I'm not going to get into the motivation and existing solution and what have you. So let me just
Actually,
jump in.
I have a question around the motivation. Is there any application that is not a job?
So I call this schedule plugin Sakara. So for Sakara, no, it doesn't have to be a job as long as a group is defined. I'll go over what the group is. The group could be a pod group.
Right, but as part of the motivation, is there motivation that is not jobs?
Yeah, so it doesn't have to be a job.
Yeah, I understand it doesn't have to be, but speaking of use cases.
Use cases, what would be, for example,
The,
I
that
guess
that that would answer the question of whether it makes sense to have it outside of Q at all.
I see. I see your point. Okay. So if I have a service, for example, that consists of a few pods, and I want to place them in a topology awareness fashion, that's not a job. Um, but no, I don't have specific examples. A good question.
Okay, you can continue. Sorry.
All right. So here's an example of how um, I have this group of pods depicted here in green on the left that has 8 pods. And by homogeneous, I mean they all have the same resource requirements. So typically a deployment. Okay, and I want to partition those in such a way that at the rack level, I want to have it 2 ways. So soft, meaning that ideally I would want 4 pods on one rack and the other 4 on the other rack, but it could also be 3 and 5, or if I specify soft. If not, it will have to be a hard constraint. In any case, so you want to partition this 2 ways, and within a rack, I want to pack the pods that land on that rack on the same node, if possible. So the most packs on nodes, put as many pods as possible on a node. Okay, so given the current state of the cluster like that, it has 3 racks and the nodes are defined that way. And the grade is the allocated amount of resources on those nodes. So what Sakara would do in this case would split it. In this case, it was able to split it 2 ways. Half of it, 4 pods landed on rack 0, the other 4 on rack 2. Nothing on rack 1 because there is no way to pack as many as possible on rack 1. See, it wouldn't have been a good packing. Whereas on rack 0, it was able to pack 4 on one node, and on rack 2, it was able to pack 3 on one and the 4th one on this extra node. So that's one possibility. That's one example. Another example is here is a set of 6 pods. User specifies at each level, you specify one of handful constraint types, which I'll get into if I have time. That you have pack at server on the server level, and on the node level you spread, but you don't want to spread that. You spread them in a range because you might not want to spread them too thin, meaning ones, for example, on each node, and you don't want it 2 cores more than 4. So it says in the range 2 to 4 on each node. So the 6 packed on a server here, the nodes are the leaves. The server is the physical server. The node might be a VM on that server. So in here, the all 6 got packed on the server 1, and they got spread out. And in this case, it was able to do the minimum, which is the 2. On node 3, you could have put 3, which would be in the range, but then you wouldn't have been able to do a 1 because you have a minimum of 2. So that's how it got placed. Just to relate to tasks and queue, the corresponding way of placing in tasks would be pack at all levels, period. Okay, so how is this implemented? As Wei mentioned, so I'll just fly over this. So I'm using config maps, but could also be implemented as a custom resource. We can talk about implementation later, but here I'm showing a config map that defines the group. It could also be a pod group, and actually I have it running with pod group as well. So here a config map that defines the group and the definition. Oh, I'm sorry. This is the config map that defines the topology of the cluster. Sorry, this is the topology of the cluster. So again, it could be a CRD. It could be through labels on nodes. There are several ways of implementing this. So here I'm showing you a config map that defines the topology as a tree, like that. So these are the racks and so on and so forth. It also defines the levels. So we have a rack and a node. That's the topology. As far as the job or the group that is to be placed, so that's again, I'm using a config map, could also be a CRD or a pod group. Pod group doesn't have most of this, what would be specs in there, so we'll have to extend it. So I need obviously a name for the group, the size of the group, which is a member or something like that in a pod group. A priority for this group, which could be derived from the priority of the pods, and most importantly, how you want them placed. So these are the constraints. So at each level, the type of constraint at that level. So we have spread, pack, range, partition, factor of, as far as I can remember, maybe I missed one or more other ones. So this is how you define the group. The pod itself, or the deployment in this case that is placed, consists of 6 pods. You just specify the name of the group. And if this is a pod group, then obviously you put the label of the pod group with the name of the pod group and the name of the skin. That's it. And in this case, it got placed. It was asking for spreading across racks and packing on nodes. So the 6 got placed that way. I briefly met, okay. And the status, if you will, of how things are placed is using the config map was written back on the config map. But if this was a CRD, it would have been written in the status. So another piece of information that is filled in here, which is the rank. So all members in the group get a rank, which defines the distance between them. So it starts at rank 0, which is typically like if this is a master and worker in a job, then 0 would be the master, and then ranking how far each pod is placed from the master, because the application may need to configure itself with that information. So that's also provided in the config map and provided in the pod itself as a label. So the rank gets put in here, the status obviously, and a bunch of other things. Okay, so one thing that I'm done with this is preemption. So Sakara as well supports preemption at the group level. If cannot place a group given the constraints for placement, then it will try to preempt a lower priority job as a whole, not a job, a group. And groups there could be one or more groups. Lower priority would be preferred, and they get preempted, and the new one, the high priority one, is placed. And then we can talk about details of how this thing works. And really at the core of it, there is a solver, if you will. And that solver is the thing that decides on the placement. That is called the pre-score extension point. And that solver could be a very simple one. It could be a more complicated, solving an optimization problem. Obviously, I don't want that here. So I have a very simple implementation of something called a SIG, and that's already open source, and there's a paper that talks, a publication that talks about that. I ran this thing in a research environment here. I was able to place groups of 96 pods. It took like 8 milliseconds to run through this thing. So I'll stop here. Any question?
I have a couple questions. So I think for the first user scenarios, I want to understand why the co-scheduling plus the vanilla part-to-party spread cannot resolve the user scenario. The first one, I think your workload has two requirements. One is scan scheduling, because you want that is go to the same rack. Otherwise not. The second one is that you want to go to topology spread. So for the first scenario, I mean, why we invented another one to resolve this. For the second one, I can see some gaps, like you want specific range, then some existing plugins cannot fit. Yeah, but the first one, I'm not sure why it's.
I actually would like to add to that question, asking how many of these scenarios that you presented are coming from requirements, because we can do the API as flexible as possible, but is it going to be used? And John here can attest to like how we made like the DRA API so complicated that it was very difficult to maintain, and the proposal had to be reduced significantly to address the use cases that are actually necessary, so that we don't end up with too much complexity. So that needs to be our first question should be around do we need all of this, first of all?
Right.
And
Very good
which
question.
ones do we need to optimize?
Right, so let me try to address that. The topology constraint that comes to mind, obviously, is the pack at all levels, and that's what Q has done. Because you want things close to each other so that you minimize communication. We did experiments, and I think Jose is on the call. He can chip in. So Jose did some experiment, generative AI type workload, different kind of networking arrangements and all gather and other topologies for communication. And what he found out is it is not necessarily the case as you vary various parameters. Jose can describe more detail. We have a paper that's in review. I'm happy to share it with you guys. That shows that in some cases, pack at all level is not the optimal way. You may want to pack at some level and spread on another one. So we have documented experimental cases that show that you need that. And
yeah, pack on some level definitely makes sense. Basically, we can use node affinity to restrict the placement to what kind of group we call it, as long as we label the group nodes properly. And then within that particular group, I mean the particular node pool or whatever terms we call it, then we can do add further scheduling directory to restrict the further placement. But there's no problem. I mean, but my question is more on why use the combination of existing plugins cannot resolve, especially like the first requirement.
would this combination work as a group? as a gang?
Yeah, and co-scheduling plugin can do that, right?
Right. Co-schedule, I understand that, but you rely on each pod being placed independently until all of them
Yeah.
are placed. But the decision to place each one doesn't depend on how the others are placed.
Overall, you have to schedule one by one, right? So
Right.
you may make different decision based on the latter part scheduling outcome, and then you make an overall
That's
decision
right.
which kind of group. Yeah.
Exactly. That's the whole point. Where so
Yeah, basically, I mean, my point is the same requirement.
the
We can
requirement,
make the code scheduling algorithm better because sometimes especially the decision of the first part of the group will be less optimal, which cause we end up with non-optimal decision for the whole group,
yeah,
right?
that's
So
right.
my point is that it's a common requirement. So why not split them into individual plugins and make each plugins more generic and more optimal so that, for example, this plugin can be used in your case and can be also used in other case, which doesn't need to like the range or some other requirements. So I think this is maybe the direction of open source community wants to focus on. For example, if you guys have bandwidth, maybe come up with a generic gas scheduling or just improve existing one to fit your use case as well. So that will be a win for much wider audience instead of just using the Sakasa plugin to
Yeah.
resolve. Yeah, that's my point.
Right. So there is another case which came from a requirement here at IBM. Actually, I didn't talk much about, which is I mentioned it, the multiple of. So you want multiples of 2 or multiples of 4 or 6 or 8 or whatever placed together. So that's hard. I think it's hard to do on a pod by pod basis. It's doable though. I agree with you, Wei. And the
Mhm,
only point here is that the decision for placing all pods is done in one place. So you do that at one place rather than placing one at a time. And you're absolutely
mhm,
right. You will get different answers. You may get different answers. So
mhm,
with this one, hopefully you will get a better answer than placing each one at a time. Because
mhm.
sometimes if you place each one at a time, you may want to backtrack and say, oh, would have been better if I put pod 1 in that other place because now I'm stuck with pod 39.
Mhm, mhm. Yeah, I'm fine with this part, especially we can have multiple plugin and doing. I'm fine with doing overlap thing and see which one will win and see as time goes whether we can merge some of the functionality into a generic one.
Yeah.
So
Would be interesting to compare actually. I'm gonna do
yeah,
that.
yeah. Go ahead, John.
Yeah, so this is really interesting. I mean, I'm definitely seeing a lot of these same problems talking to some of your colleagues at IBM Research as well as just with the DRA community in general. And we have some um, primitives that we're building into DRA that help with a little bit of this here and there. One thing though, I keep seeing over and over from different people is like I'm wondering if our scheduler extension points are right. Like right now, as I understand it, and I don't know the code well, so I might be completely wrong here. But when we specify the scheduler name in the pod spec, it defines which plugins get activated. But what I'm wondering is if there were a way, and I don't know if that's true, that's what I heard.
It's not that true. Basically, you define a scheduling name that basically represent a series of the configuration of the scheduling plugins you want to bundle together to use
Okay,
that set of plugins.
okay, that makes sense. What I'm wondering about is there a way to, or should we have a way to actually bypass Kube Scheduler completely? And so separate out the
Yeah, you
actuation.
can. You
Okay.
can.
Okay,
You can.
cool. So the idea is that separate out the actuation, even if you maybe eventually use Kube Scheduler for actuation of like the binding, right? But like that way you could segregate nodes. You could say this set of nodes uses, because we don't have a way to share the resource reservations which would also be a super interesting thing I've heard from other people in the HPC world, like, why don't we have resource reservations? We didn't need them. That's probably why. Like, but I'm wondering if we can start to think about longer term how we might restructure some of our primitives so that some of these more esoteric use cases can, or maybe they aren't esoteric anymore, but used to be esoteric, can kind of like be built over time before coming back into the nest. I don't know. Like, it's kind of what you're saying, like you want to bring the things in eventually, but at some point I'm wondering if the pod by pod scheduler, which we have today, might be good for certain types of workloads, and we might need to segregate either by node or by something. I mean, node's probably too crude, but that could be a start.
Label structure, yeah.
Yeah, something,
Yeah.
right?
Yeah.
And say this set of resources is managed by this scheduler, which isn't pod by pod, and this set of resources is managed by the standard cube scheduler. And if we can start to think about how we might do that, right? We might.
Yeah, that's totally doable, and even low hanging fruit, I would say, is just that.
Really?
Exclude some nodes out of the default scheduler's cache. So that is basically we just can form into a node exclusion selector during the scheduler startup. Then in default scheduler's world, we only maintain a portion of the cluster instead of every node. That is basically what you mean, right?
Yeah, basically, and be able to tell, okay, all these other nodes. It gets a little bit trouble when I've talked to people. It's like, well, we want our daemon sets to just work normally, right? And it's like, well, sometimes it's hard to have the best. You're kind of, if you segregate out those nodes, then you need to somehow re-implement that. I don't know. So we can talk more about it, but that would be great. I don't know how I would proceed. Maybe we can start to put together a capper on something like that.
That can better fit multiple scheduler coexisting.
Yeah, exactly.
Yeah.
So
That's all.
something that you touched on, John, which is, I think, the idea of having another scheduler where we can experiment with things. We already have that as part of the Kubernetes project. Is the scheduler plugins repo, which has this separate.
But does that assume the plugin structure, right? So
yes.
that, and I'm saying we would bypass all of that, because say we want to do what Aser here is doing, which is take 1,000 pods, look at them all at once, do a mass placement, and then execute on that as one, right? Rather than as a pod by pod execution. And I don't know if the plugin framework we have in scheduler right now is amenable to that kind of thing.
Right. So in that case, we are talking just about a classic second scheduler, which you can write from scratch.
Yes.
Except that, you have to, from the pods, you have to choose a scheduler name at the beginning, right?
Okay. Yeah, that would be fine.
Well, Q is doing the similar thing. So they are still using a scheduler, but they like almost have the assignments already prepared.
Right.
Right, but if you want to make sure that if Q wants to make sure that the pods are really scheduled the way they are scheduled by Q, a lot of functions that are already in the kube scheduler have to be also performed by this Q scheduler. You know, the
that's hard.
Image locality and this and that, and it's like, I'll stop here.
Yeah, I think we have other topics. Maybe we should stop here, and about whether to put the design cap. I think because right now the design is based on the imputation of scheduling framework, so to me it makes more sense to explore what's the when the plugin comes out, we can see the code, we can see how it goes. If we want to put it into KQ, maybe it's totally revamp of the whole design as well as imputation, right? So, yeah.
I have one more question regarding that.
Mm-hmm.
So if we don't change the scheduler implementation and we still can schedule like pod by pod, does it make sense to have topology or scheduling implemented in this way? Don't we use
that is why I do really want to see Azure use the scheduling plugins to achieve this. I do want to check that. Yeah.
Sure. I have it. It's not. Yeah, I'll put it out there.
Yeah.
I have it running.
Yeah. Otherwise, if you are using a controller instead of the scheduling frameworks mechanics, then I will say definitely you should go to some controller like framework like KQ. Yeah.
Right. No, there's no control. This is just schedule plugin using of course, using the pre-enqueue quite a bit, the same way that
I
the
see.
co-scheduler does, and the reserve and permit, because you need to let them out at the end at the permit.
Yeah, let's see the implementation details, especially the difference with the existing code scheduling plugins.
Okay.
I want to see if there's some overlapping and some. We will see. Yeah, which one is maybe better, more generic for the GAN concept.
What is the conclusion way? Is it to have another meeting where we dig into the implementation?
I think it's okay to proceed with scheduling plugins cat and evolve there first. And then it doesn't mean we end up with there. We have other possibility if we think, okay, it's too much similarity with existing code scheduling, and we can convert them into one generic one, or we see there's a lot of similarity with KQ's design principle, we can emerge into KQ. Yeah, but if we don't have the design and the implementation details, we cannot give a conclusion here, I think.
Right. So basically, what I'm hearing is a cap for the scheduler plugin repo for now.
Yeah, I think that's a good starting point.
So is the implementation already possible using the existing framework, or do we need to extend or change anything? For instance, is it possible to do preemption?
Yes, I'm doing preemption with the current scheduler plugin. I didn't make any change.
So you didn't change this. You didn't change the scheduler framework. You're using it as is, and you're just implementing the endpoints. Is that what you're saying?
Yes, exactly.
So how is it possible to preempt the group of pods?
You know the groups. I mean, the Sakara, the plugin, I can figure out the groups that are running in the cluster. It can figure out their priorities. We'll order them. We'll go through them, preempt one at a time. What happens is it's gonna decide on the victims, and then we'll just delete those pods. They go away.
So I think I would like to dig in the next session about the implementation details. What in parallel to the, I mean, you can submit the CAP proposal for the scheduler plugins repo in parallel. Yeah, I guess I would like the Q folks to come to the meeting. Ideally. Yeah, as I was saying earlier, one of the challenges is that if you implement this functionality in Kube Scheduler, is most likely unusable for Q. So it's gonna end up being duplicated in Q because of the priorities that Q has to pay attention to. Whereas if you implement it in Q, then well, we can just tell everybody use Q if you have this needs, and you have job support, like full queue management, quota management, plus topology awareness in one component. So that's what I'm still struggling with as a long term. I mean, as a short term, yes, we can experiment in the scheduler plugins repo. But long term, the question still stands of whether not putting in a queue is the right choice. So I think it's worth either having another session with the working group batch or bringing the folks to come to the meeting here to listen to the implementation. And implementation API and so on. But okay, I think
Although I think we can discuss offline in the Slack channel whether we want to bring another session on the implementation details. And today maybe let's finish the other topics. Okay, sounds good. Could you see my screen?
Yes.
Okay, another proposal is from the schedule plugins from someone who wants to propose some plugins, and one of them I think is a good extension for existing resource feed. So basically the high level idea is that what we offered right now in the vanilla Kube scheduler score plugin, there's a plugin, unified plugin called resource feed, can serve as 3 flavors. The scoring strategy can be most allocated. That means it's a bin packed and least allocated, which means we want to spread the parts as much spreading as possible. And the third one is a special form of how you describe what kind of resource can be packed to what kind of extent, and then what kind of score it will be looks like. So, but overall, this scoring strategy just applies to all the resources you specify. You cannot say, okay, I want CPU memory to be more spread, but make GPU resources more sorry. I cannot achieve that spread the CPU and memory resources while also make GPU resources more bin packed. So that is why what's the motivation of the first plugin comes in. But the design, I think, doesn't work another scheduling plugin. Instead, we can go enhance existing resource fit on the request to capacity ratio scoring strategy. So the plus part is the hypothetical part, which doesn't exist today. So basically, we don't have the option to specify what kind of resource name you want to do, what kind of utilization to score mapping. So what we can do is that we can say, okay, for GPU, sorry, this should be CPU and memory. Yeah, specifically wrong. So basically, you can see for GPU, you want if the utilization to 100 will be perfect because it's scored to 0. And for other, so there's a typo here. This will be CPU and memory. For CPU and memory, now I want them to spread. If there's at 100%, there will be a score much less. So this is my proposal so that this can be fit for this kind of scenarios. And I don't think we should apply this new API spec to most allocated and the least allocated, as long as this fits this kind of scenarios. Yeah, I just want to bring it up. And
I actually think we should, because that's probably the most common scenario is you're going to use most allocated for GPU and least allocated for the rest.
yeah, exactly. One practical use case is that in the inference stack, users usually put the inference path the same location, same cluster with the like the vector DB path. Vector DB doesn't use a GPU, but it's used a lot of memory. But for the inference part itself, it uses GPU, but not that memory. So that can be a good combination for building the inference stack, actually. Yeah. So for this one, I don't want to take too much time. So
I
Dominic,
just have
do
a
you
quick
want?
comment maybe, or a quick
Sure,
question.
sure.
So when I look at these weighted things, so you look at multiple resources, each one has a weight, and at the end you have a weighted sum basically. And I'm just wondering, should there also be a way to specify a strict order, like pack on this first, and then you know, like you have it here, or spread on this, in that very strict order, do it in order, rather than a weighted sum. You see my point? Or
By
there are no
the
use case for it. I'm just wondering. You know, I don't feel strongly about it. But
if I interpret the order, you mean properly? Do you mean the weight here? So basically, is
so
that
in
what you
addition,
mean by?
instead of weights, basically allowing another policy instead of a weighted sum as here, that
Mhm.
you pack on the CPU first and then you spread on memory.
Oh
However,
no, there's no. Yeah, it's based on the weight. For example, if the GPU reach 100%, basically it's BSON. It's a dominant factor memory in this
Okay.
case. Yeah.
Okay, got it. Thank you.
It will give you the same effect, or roughly the same effect, but
Yeah.
the framework is not ready to do first this, then that, because it's implemented with weights already. Bobby?
Yeah, Bobby, go ahead.
Yeah, I was wondering if both weight and score are useful here, because I guess, you know, score can be up to 100. And so are you going to multiply that weight by that score?
Inside this plugin scoring, yes. But
Inside
that
the
is
plugin.
only among the CPU memory versus GPU, instead of versus other high-level plugin. It's just within
Yeah.
this plugin. Yeah.
I see. Okay.
If you want to make a dominant factor comparing the other plugin like image locality, you have to configure the weight in another place. Yeah, you know that.
Yeah. All right, cool. Yeah, thanks.
Okay.
Cannot we like achieve the same with existing plugins? So
Yes,
have,
it's an existing plugin. It just doesn't have this kind of spec right now. So there is a doc. This is the current configuration. There's no API spec. You can specify which particular resource you want bin pack or which particular resource you want more spread. Either way, you can just choose one. Yeah. This is current spec.
okay.
So Dominic, you're proposing an Asian-friendly slot for the meeting?
Yeah, of course. So I talked to Kanzai. He wasn't able to join the meeting, although he was interested because it's 2 a.m. So yeah, we are thinking whether we should accommodate somehow other times as well. So possible proposal is to have maybe 2 separate meetings. The one that covers both Asia and Europe, so we could meet more regularly, and keep the US time zone meeting optional whenever there is anything in the agenda. And
I think I may also consider Europe-friendly time slot, right? Because a lot of right now, a lot of contributors are located in Europe. So yeah, we can do like rotating bi-weekly meetings, one US friendly and one Asia/Europe friendly. Yeah, that's totally doable.
Can you lead like the pool? Like, can you make a pool, Dominic? To choose a time.
Yeah.
yeah, I probably won't be able to do it soon because next week I'm completely off, so I have only one day and a few things to do. But yeah.
Yeah, no worries. I will talk to
And-
Kensei to come up with a poll.
But
For
yeah,
a while in the
can
past,
follow
I
up.
remember we had 2 meetings.
Yeah,
But the Asia ones didn't get much participants.
attendance.
So after a while, I guess we stopped.
Yeah.
Right. I heard about that. That's another thing. So not sure if we want to like make more meetings or just mix having
I mean,
one
the-
here and here.
Back then the contributors were mostly in North America, but that is shifting now, so
Yeah,
it makes sense.
That's true.
Yeah, sure. Okay. The last one, John.
I just
think
wanted
we
to,
yeah.
yeah, I just wanted to, last week or last time I talked about a bunch of things. There's new ones too. A lot of them are scheduling heavy, not really node heavy. I just want, I'll try and have a better list for you next week, early or late, or tomorrow or early next week. But I wanted to make sure people were aware and not startled by new things popping up. That's all.
Okay.
I'm still gonna be startled.
Yeah, we will figure out how to spread the scheduling stuff on the review things. Yeah. Thank you for the heads up.
Yep. Thank you.
All right. I think we will work on the poll and have an offline discussion whether it's needed for another deep dive session for both work group batch and SIG scheduling. And for this one, I will follow up with the author to come up with an upstream cap to enhance the scoring strategy. All right. Thank you, everyone, for joining today's meeting. Yeah.
Thank you.
See you. Yeah.
Thank
See you
you.
in 2 weeks.